Good morning, everybody. This is Gavaskar Reid from the New York City Department of Education Career and Technical Education Office. Today, we are featuring our splendid partners from Engineering Tomorrow. Some of you are familiar with them. They have been featured before in our past CTE commission meetings, and I must say that these folks here, they are very, very dedicated to empowering our schools and helping our young people, and I'm very, very excited to have them today. And you could have been in any other workshop today, but you chose to attend this one. And I thank you for that. I want you to please pay attention to the chat box. We're going to be dropping some important materials and links. And I really encourage every school that's in attendance today to please sign up for their services. They have free virtual labs, free pre-engineering kits, free curriculum and lesson plan resources. And I remember when I was a teacher, these are the kind of things I look for. I've had to attend so many PD workshops and events, and they didn't do anything for me. But in terms of you guys wanting authentic, tangible, concrete materials that you can use to actually strengthen your lessons, these are the folks to work with. And especially being somebody from the industry engagement team, you know that we're very, very big on partnerships and collaborative relationships with folks who are professionals from the industry. You get all of these in one package. You have the opportunity to work directly with professional engineers and college engineers as well. And these are the opportunities that my team and I get inquiries about all the time. So if you're looking for these kind of resources for your CTE class, your STEM class, you are in the right place. So I'm going to turn it over to Tim McNiff of Engineering Tomorrow. Tim.
Well, good morning. And Gav, thank you for that wonderful introduction. Be honest with you, folks, I have been guilty when I start off about bragging about who we are, because I say immediately, we have a great story to share and a wonderful opportunity for your kids. You preempted that for me, Gav, so with appreciation, thank you. So with my colleagues this morning, we represent a nonprofit organization called Engineering Tomorrow. And our singular focus here is to be of service to you and to your students. I'd like to do a quick overview of Engineering Tomorrow and then pass it on to Milton Davis, our engineer, who can do a much deeper dive to give you an appreciation of what our curriculum is like and how we engage your students. But here's our premise. The premise is just about everything, if not everything, that we enjoy and label a quality of life for us, we have to thank engineers for that. Engineers have a fingerprint on all of what I just said. We even say to our students at some point in the narrative that we have with them, did you brush your teeth today? Well, thank a chemical engineer. They're the ones that did the toothpaste. And a lot of folks don't connect those kind of dots. So if that is the case, and we can all recognize this, there's a deficit of engineers in this country today, and that deficit, if the projections are correct, are going to get larger. So Engineering Tomorrow is all about building a pipeline where we can produce more engineers in the future for our country. What I love about this mission, we're intentionally starting with high school students. May I share this with you? When I got introduced to Engineering Tomorrow, I was serving as the school superintendent for the Catholic schools in New York City. We had 50 high schools. And I say this to make you laugh, but it's true. I said, thank you, but no thank you, when they first approached me. Here's why. And you could agree or disagree with me. I said, there's no shortage of STEM programs that are out there that schools have access to. But the vast majority of them, from my perspective, and I don't disparage any of this good work that all their people are doing, but they're vendors and they wanted to sell me a product. And then I had to pass it on to a teacher who by and large didn't have engineering experience, and they had to deliver that product. A lot of things got mitigated in the process. So I wasn't that crazy about the thing. Here's how they cut through the reservations for me very quickly. One, everything we're going to talk about today, folks, is free. There is absolutely no strings attached. There's funding with Engineering Tomorrow to do this today and in the future, where we will provide for all of the cost to the teacher, school, to the students. The second thing they said was everything that we do has been created and will be delivered by a professional engineer. This became a turnkey operation for the teacher, not an added administrative chore to do. So turnkey that the teacher selects any of the 22 labs that we offer, and they select the time in which they would like to have these labs delivered. So it was really a turnkey operation. The quality, and you're going to see that when you listen to Milton talk, is just superb. And you know, because we're in the virtual world, every child gets a box like this with all the supplies that they're going to need for any of the labs that we do. Whether that student is in your classroom or where we are today, if they have to be at home, that doesn't stop our labs from being operational because they get this. Again, it's all free. The other unique piece of that really caught my attention when I was being introduced to this is not only are professional engineers being presented to you, but we have a bullpen of over 50 college students from great colleges all over the country. And we get 2 of those students to engage your kids in every lab that they do. Some of that's the most richest and robust conversation that happens in the course of this lab because of the age similarity among the kids. I absolutely love these labs. I'm since now the executive director. We are in a virtual world, obviously, and that is what is making us most effective. And we're in 25 states. We will do over 50,000 kids this year. But because Engineering Tomorrow is New York City based, it's our obligation, and we accept it, to make sure every high school in New York City is at least aware of who we are and our desire to provide this opportunity for your students on that. So in a nutshell, that's who we are. I think for the time that we have available to us today, we better serve you if I pass the baton on to one of our engineers. And Milton is a phenomenal example of the quality of people we're going to put in front of your students. Milton's a full-time engineer at NASA and is doing some exciting work with NASA. I'll let him elaborate on that if he'd like to. But not only do we bring these adults in front of your students who've got the professional qualifications, and you'll see this through Milton, we bring the adults who know how to communicate with high school students and how to engage them. You know better than anybody how important that aspect and that skill set is. So Milton's going to talk a little bit about aerodynamics, one of our labs, but everything he's saying, you really can translate into any of the other 22 labs that we have. So thank you for the time that you're giving us this morning. I'm going to close by just saying, please accept what I'm saying because it comes from the heart, not the mind. We really have a desire to support you, be of service to you, and to do what we can to help children. So Milton, it's always great to see you, even if it has to be virtually these days. I thank you for your time, and why don't I pass it to you?
Thank you so much, Tim. Hopefully you all can hear me, and thank you for the awesome intro. And what we're going to do, as Tim stated, is we're going to walk through this lab just like I was going to provide it to your students, which I'm grateful to have an opportunity to do that. So the lab that we're going to work on is aerodynamics. And what we try to do every time is these kind of 5 steps in a session. We're going to relate to the students, right? I'm going to talk some about my background and my path to the STEM field, indicate why this is important. We're going to attach some of the theory or tie some of the theory to an actual application. They'll have a challenge to complete, and then we'll talk about next steps. All right. So I'm going to walk through this as if I'm going to present, I would be presenting to your students. So welcome. This is our aerodynamics lab. And our challenge today is to develop an air vehicle that will achieve 2 goals. One, it will remain in the air the longest possible time it can remain in the air. And 2, it will travel the furthest distance it can travel. This lab was not created by me. It's created by one of my good friends, Edgar Martinez, who is an outstanding civil engineer, but also Joanna Cottle, who's a great teacher and engineer. And maybe even more importantly, students are involved. And that helps us ensure that anytime we present a lab, it's relatable. And again, this is our challenge overall. The challenge will be to balance all the forces on aircraft to ensure that it performs, right? And we'll walk through the entire engineering design process to do that. But I would be remiss to jump right into this and not tell you a little bit about my background. You got to excuse me, this is going to be a little corny, all right? So this is my journey into STEM. When I was young, we didn't have like Instagram, Snapchat, TikTok, all that jazz. We had something called MySpace. I don't know if I would consider that social media. So I loved a few things: sports, I loved chess, and I loved RC cars. I would race these RC cars up and down the street. I chased my siblings up and down the street with them. I'm just joking. I'm serious. I also was into something called TOEs. And by TOEs, I didn't want to be a foot doctor. I didn't want to be a surgeon, podiatrist. Theories of everything. I have no idea why. I'm in physics class wondering, are you serious? This entire universe came from an infinitely small, infinitely energetic particle. Is it possible that I live in another dimension? Tim lives in another dimension, 11 dimensions. This is crazy, right? But I didn't go to a great school like you all attended. So I was really just happy to get out of my school. I always say the most advanced technology I had in the school was a typewriter. And I self-enrolled in community college. My counselor said, Milton, you got to figure this out. What are you doing? You're a smart guy. What are you doing? So I said, hey, well, I really love these RC cars. I really love these theories of everything. And then it all snapped for me, aerospace. So I was very blessed. This gentleman called someone that day. I still remember the guy's name, Frank Bauer. And we talked for hours and hours about aerospace and opportunities, and they actually hired me. And what I want to say to you all is, as students, you all may not know exactly what you want to do, but just continue to persevere, have some resilience, have some, just think creatively, be open to opportunities, and you'll make it as well. So after I started interning there, I transferred to Purdue West Lafayette, where I received my degree in aerospace and aeronautical engineering. I later got a master's in project management and system engineering from Hopkins and pursued a robotics master's as well. This is me as an intern. You can see a much slimmer gentleman. That's not important. What's important, though, is that we use the same engineering design process back then that I used at NASA today, and you're going to use on your air vehicle. What am I passionate about? I'm extremely passionate about you all. I mean, I have a nonprofit called Future Innovative Rising Engineers, where we do all things robotics, rocketry, autonomous vehicles, RC cars. You know, I love RC cars, entrepreneurship. And that's why I've partnered with Engineering Tomorrow, which is also a nonprofit. I would just love to expand STEM opportunities to all of you. So, but what do I do on my day job? And this link is challenged to show up, so I'll move it here. What I do on my day job is I am the space vehicle manager for a mission called Awesome One. That's Awesome One. So just like you have a challenge today with your vehicle, our challenge with NASA is we want to build these large habitable structures in space. We want these large habitable structures to be built on Mars and on the moon, but our rockets, the fairings are just too small to bring them up. So what we're thinking is, what if we could build them? Take the pieces and build them in space. And you can see this robotic arm, which pseudo machine learning, where it learns and behaves and learns how to adequately build these parts. And we're performing some level of additive manufacturing, right? Where we're going to protrude some longerons, some beams, so that we can actually put structures together in space pseudo autonomously. So that is a little bit about my background and what I do. This is just kind of overview of that background and what I've achieved. What I'd like to do with you all is learn some things about you and engage you on the topic, right? So here's our first question I'm going to ask you. If you had to design a helicopter, and we're all talking aerodynamics here. If you had to design a helicopter to operate on Mars versus on the Earth, what would you consider? What considerations would you think about? You can place them in the chat. You can say them out loud either, right? What things would you have to consider? And I'm talking to you as teachers, please. Heat, excellent. Yes, heat, that's great. I love it. Thank you. Gravity, excellent. Thank you, Farida. Thinner air, bigger rotors. Oh man, you all, well, I would expect some awesome teachers to get it all right. Dust, right. Contamination, drag.
I keep power.
Power.
How to
Oh
maintain
my,
power.
hey, we're killing it. Power. Okay. So what we're going to do, I'm going to play this short video and you'll see some of those considerations now.
First helicopter to fly on another planet.
The challenges are many. Ingenuity first must disconnect from the belly of Perseverance. It's a multi-step process already underway. This picture taken Sunday of the detached debris shield. Once Ingenuity is detached, it has 25 hours to gain enough charge from the sun to independently survive a Martian night. Then there's the challenge of actual flight. Mars' atmosphere is only 1% of Earth's atmosphere, so engineers had to develop a special twin rotor system that could provide the necessary lift to get airborne. Also in flight, the helicopter has to control itself, making 500 tiny adjustments every second. Bob Balaram is the chief engineer for the Mars Ingenuity project. He says it's every bit the Wright brothers moment, it's just on Mars.
I wish we could go back to Kitty Hawk and ask Orville and Wilbur Wright what their thoughts were. It's very similar in spirit.
Perseverance has already sent back Martian images and recordings of wind on the red planet. Perhaps a small taste of what's to come when the helicopter takes off on April 8th, just a few feet north of where Perseverance landed. The flight will consist of a takeoff, a climb to an altitude of 15 feet, 30 seconds of hovering, a turn, and then landing. If successful, Ingenuity will have made history with every move. The first powered flight by an aircraft on another planet.
All right, so I can step back from presenting this to you all as to the students, but you all are getting it right. I mean, you hit the nail on the head. The main things are atmosphere, energy, weather. Someone said radiation. Outstanding answer. You can't throw an iPhone in space, right? All these different considerations that you have to consider. Excellent answers. Then another thing we do is we try to relate to the students, right? So I don't like to just jump into a presentation, have talked about myself and have not learned something about them. So if you could entertain this, right? If you could go to slido.com, and I'll type this in the chat as well, slido.com, and you could type in those numbers, 440-770. It allows me an opportunity to engage with you all, just like I would engage with your students if I were in the classroom. What we find is by telling our story, one, right, relating to them that way, and then by allowing them an opportunity to just speak to us about something that's going on in their lives, even if it's just something fun like this, they're just more open to receive the labs. Also, sometimes we have labs early in the morning. So, you know, it's really important that if it's early in the morning that we just kind of get their minds flowing. They've just jumped into the classroom. They may be a little hesitant to engage, and this allows us to engage, all right? So I said, if this is the question, if you could go anywhere in the world and COVID-19 and money were not a concern, where would you go? Where would you go? Costa Rica, nice. I love that. St. Thomas, that's great. That's great, great answers. Orbit, that's me. I mean, if I could get my wife to buy in to allow me to go into space, I mean, sheesh, I'm still trying. If anyone you know my wife, you know, maybe you can help there. Ireland, that's dope. Great. Jamaica, excellent. Argentina, cool, excellent, cool. So we're getting it. I see some Iceland's in there, the Grand Caymans, somewhere just warm on the beach, the water, away. Yes, excellent. Mars, oh my God, seriously, Mars. So since you said Mars, I mean, that's the difference between Earth and Mars. I mean, Mars has a magnetosphere which protects us from radiation. I mean, the Earth has a magnetosphere which protects us from radiation, and Mars does not. That's one of the differences and reasons why we don't currently easily support life on Mars. Excellent answers. So this is just our engagement, you know, like some students, and I'm showing the example from previous classes, students say all these different answers, then we open up the mics and then we just talk about it. Why would you like to go there, right? Excellent answers, great. And then this is another question, you don't have to answer it. We do the same thing. Like if you could eat only one meal for the rest of your lives, what would it be? And we just get all these crazy answers. Then I learn about some new food. Maybe I don't need to learn about that new food, but I do. And I actually pick up some ideas of things that I can do with my own kids and wife. And then another question, you know, would you rather explore Venus or the universe or the ocean, right? And we'll get various answers on that one as well. And one of the reasons I highlight that one is because students think of aerodynamics of being limited to gases, but aerodynamics is implied to any fluid, whether it's a liquid or a gas. So we get a chance to talk about that. So here, this is going to give maybe about 4 billion years ago, right? That's right. Here we're going to have a short video, and I won't watch this video now, but what this video goes over is explaining how lift is created. And what's really important for the students to understand is the reason why wings have camber is because for lift to be created, there needs to be a change in momentum. When they're designing their vehicles that they're going to design in this class, there has to be a change in momentum for lift to be created, which is very important. So then we talk about this, what are those 4 forces of flight, and how do they impact how you would design a plane? And once you understand the 4 forces of flight, and that, you know, it's not that any force is necessarily a bad thing, it's just all about how you balance it, then we transition to this. How does my plane, you know, move, right? What are the main 3 things that I need to consider when a plane is moving? And you know it as roll, right? As yaw, and then as pitch. Rotation about that front to back axis, then rotation about the side to side, which is pitch, and then the vertical axis, right, which is yaw. So right then, now we engage the students here. So there's one thing for me to say, this is how I control the plane. It's another thing to say, you know, what features, what surfaces would I create on a plane in order to reach those 2 goals? And what were those goals again? The first goal was that it stay in the air the longest, and the second goal is that it traveled the furthest. So now we just jump right into it. I'll ask you to do this with me. I actually, you know, pull out a sheet of paper, and we show them how to make their first plane, right? So if you want to entertain this with me, that'd be great. So I walk through this plane, and if you can't walk through this with me right now, what we always have ready for the students, ready to go, is a video. Just in case I'm moving too quickly, they can go along with me with this video. So with this plane, what I'll have them do is create a simple hang glider. It takes a little bit of dexterity here. So I'll have them take the plane, start in the top right corner, right? I got too many sheets here. And they'll fold the plane in this corner, real time. All real time during the class. They really get a kick out of actually doing something during the class rather than me just explaining it to them. And I'm going to make another fold here. And we're going to make sure that we have good creases as they learned about the importance of drag and air resistance. So we want to minimize that. And now it kind of looks like a house. That was our first 2 steps. And then we bend it down here. And what we do here as we're bending this is we are balancing out our center of mass and center of gravity. We are shifting our center of mass back, which is going to allow this plane to balance both its lift and its pitch, right? So now what they learn is we'll fold this in half, fold it in half, just like this. Right, and it will make another, and I go a little bit slower for them, make another fold. And at this point, what they have is their control. This is their control airplane. And what I may even do is I'll add just these surfaces on the edge here. We'll add just these winglets. And what those winglets will allow for us to do it balances out and controls some of that yaw and roll, okay? So right now at this point, I would ask the students to throw their plane, right? To throw their plane. And this is what normally happens. They throw this plane, and a lot of times, it is a flying wing, right? A lot of times, the plane will fly and go straight down, right? And this is what they learn with the engineering design process. 1, you don't give up the first time, right? So 2, the next thing I ask them to do is I ask, well, what if this plane is going straight down as it's flying, it's not staying in the air long, what can I change? Which one of these control surfaces could I add? And I only want to change 1 variable at a time. So that's a question for you all. What do you think I can add to this plane to increase the amount of time it stays in the air? What do you think I can add?
The elevator.
Elevator. Excellent. So we do that, and 95% of the time it works. So I say we're going to add a little tear just in the back, just a small tear on both sides because it has to be balanced. Excellent answer, whoever said that. And then they throw the plane and it actually flies, right? You all gonna have to excuse my junky room here. I'm gonna try to throw this plane. I have to turn off let me turn off my virtual background. And let's see if it goes. Did you see it?
Nice.
Nice.
How do you like 10 feet?
Yeah, yes. So, and then that's just the first step, right? Let me turn back on my background. I want my wife to get mad in my junkie room. All right, so that's just the first step. And they document that data in a table. And they, like an engineer, write in an engineer notebook, what did they observe? What did they change? Whether good or bad, it doesn't matter. Just what did you observe? So they may add an elevator. And like you said, it stayed in the air. They timed that. Maybe they got another 1 or 2 seconds. They may add something else. And it may cause the plane to not stay in the air as long. But as they document that and they go through the engineering design process, they learn, right, exactly which improvements during this process they should add to their final plane. And you'll see that as we go through this. So other things we talk about is weight is important, right? If they think their plane is not staying in the air a long time or it's not traveling far, think about the weight. Think about how you can balance weight. And a great application of this is definitely the Boeing 787, the Dreamliner, if you all have heard about this. Just by going to carbon fiber as a material versus the aluminum and even a great material like titanium in the past, they reduced CO2 emissions by 20 to 30%. They have a 60% smaller noise footprint, and their fuel efficiency is much greater, where you can travel much further on a 787 than other planes, right? So if we were designing a different vehicle, we would consider materials. The other thing they would consider if we're designing a plane is thrust. For us, in this airplane we just made, our arms are creating the thrust. So we do need that consistency. If they push that plane harder, and if they launch it straight with a certain amount of pitch, they should be able to increase the time that it's in the air. But for other planes, real planes, these engines are designed so they can achieve a specific objective. Some of them are designed so that the plane can travel very, very long distances, but some of them are designed specifically for speed. And it's not just the engine that's designed for speed. It's even the shape of the design matters. These pointed nose cones will allow air resistance and drag to be moved further back on the fuselage so that a plane can achieve supersonic flow. So shape really, really matters. You don't need that on a commercial more airliner where you're not going to go above the speed of sound, and that drag being in front of you the way it is doesn't matter as much, right? And then we finally hammer them on this with a great example about lift, right? The camber on this plane, that's important because what it's driving is that change of momentum. If the cross section was just a circle, there's no change in momentum, right? There's a balance of air distribution both on the top and the bottom. But we can relate to them if they play baseball, and if someone throws what we used to call a screwball, but if someone throws a pitch where the ball is spinning in the air, the baseball will change its momentum and thus change direction real time while in the air. And that is example of Newton's third law, and that a change of momentum is what's driving lift. All right. So now we also talked about what someone said earlier, that this is a meta wing, and that plane I created is somewhat of a meta wing. We really want to maximize the time in the air. And you can do that, one, by just having the entire air vehicle contribute to lift at one time through the entire plane is like a wing. So shape of the wing and the design of the wing also matters. And finally, hammer this again to them, that it's balancing all the forces. It's not that any force is bad, right? We're balancing them. So what we give you all is we don't just ask the students to come up with their own planes. We first say, we give them a bunch of different sample planes. So we're hoping that they are going through the engineering design process multiple times, iterating multiple times, choosing these different designs and making a note of the features one by one as they change, variable by variable, to see which one is helping them achieve the goal that they desire to achieve. So then their second task is to make that prototype. So they kind of work with various planes. They've done their research, they've done their experiments. Now settle in on a prototype that you're going to use to really achieve those goals, and then fly it multiple times so you can verify that you've achieved the goal, right? And then we left them here with some samples. This is just a sample video of that hang glider that we developed together. You all did an outstanding job on that. And then we just go over the control surfaces again for them. And then if you want to extend this, you want to have some fun in the class, here's a fun challenge. It can be done as a competition, or it can be done in cooperation, right? So we gave you the distance challenge. Make sure that the glider can travel at least 3 meters. We gave you a time challenge. Ensure the glider can stay in the air at least 5 seconds. But there could be a cargo challenge. Maybe they can add a penny or a nickel or something. Are they able to design a plane that can carry cargo? And then you can assign some points. And sometimes I'll joke around and say, hey, if you get 100 points, your teacher will give you, 100 on the exam. Then I tell them it's not true, because the teacher and I did not talk about that. It probably won't happen, but hey, there's the self-gratification for sure, right? Self-gratification of designing a plane that really worked well. And then previously we talked about relating, we talked about theory and application. We walked through the theory and application. We talked about the challenge, and then we want to talk about next steps, because we really believe with the skills that you awesome teachers are bringing to them, and the skills that Engineering Tomorrow wants to bring to them, the next step for them is to really taste and see. And they can do that through an internship. A lot of these internships you see here, SEEP, APL, MITRE, NASA, are paid internships. Students 16 years or older, most of them can attend those internships virtually. So then they ask, well, what does it take? Well, one, I tell them it's all about their reputation. Reputation is a combination of two things. One, the great results that they have. Two, who knows about those results or their reach? How did they get that? Well, for me, if I hire a high school student, which I do every summer, I want to hear that they have great rapport with their teacher. So I tell them that relationship with your teacher is extremely important. If your teacher says that you're taking care of business and you're serious about STEM, I can trust that. The other thing is the relationships that they build. They should get involved with organizations, National Society of Black Engineers, Society of Women Engineers, Society of Hispanic Engineers, AIAA, aerospace, mechanical, right? Get their name out there, start building, and not just scholarships, but start learning about other organizations where they can market themselves. And that's how they get there. And then finally, if there's no questions about the lab, I do want to highlight just some other outstanding labs out there. We were hoping that we could have got some kits in your hands and we could have worked on this electric vehicle lab. It is very popular, very fun, right? There's also a water treatment lab, which is just amazing, right? To see how, students don't recognize that there are millions of people out there that are sick and dying just because they don't have clean water. And they themselves can develop a system where they can purify and treat water through filtration. And that's a game. I love it. How, like just Tim said earlier, how engineering and science really can increase the well-being of people across the world. It's a game changer. Same thing with bridges. Bridges in countries that are impoverished or do not have certain resources is an absolute game changer for the country in terms of the economics they produce. And we actually walk through some of the fundamental equations and tell them how to apply those equations when they build bridges, not just building the bridges, but understanding Hooke's law, understanding how to balance forces, understanding stress and strain and how that applies to develop a bridge that can support a lot of weight. And then finally, design, modeling, analysis, and simulation. They'll develop through one of our labs through a microcontroller and using software to program LEDs almost like a traffic light. The combination of electronics and Ohm's law for circuits with coding and algorithms. So, and then finally, what we talk about is, how many touch points we have. And Tim talked about this already, where we start with an engineer like me, and I'm not the best engineer. We have great engineers on that team that also present. And then with the next touch point, we have a college student talk to them. So I've walked through part of the engineering design process, but then a college student will help them troubleshoot their designs, but also talk to them about the process of getting into college. How do you obtain scholarships? How do you balance, the rigor of engineering and science and, you know, have a well-rounded life. Then finally, another engineer, it may be the same engineer they started off with, will review that design and continue to talk to them about next steps. So we'll have each of the students come up to their camera, show their camera, and we'll walk through their specific design, whether that's an airplane or an electric vehicle or their Tinkercad software, and give them some final tips and next steps. So I think Engineering Tomorrow is an outstanding program. That's why I'm part of this nonprofit. That's why I take some time away from my work to do this. And also, I still run a class that I have, and I'm doing this because I've used Engineering Tomorrow, and I've seen the impact that it has in the classroom. So with that, let me open it up to any questions that you all may have before we wrap up. Any questions, comments? All good?
Yeah.
Well,
Often get teachers saying, "Where's the fine print? I don't get it. This is too good to be true." We're being honest here. Everything is free. You will have engineers like Milton from NASA delivering this content to your students at times that match your class schedule. So far, I think we have 10 lab request forms that have come in already from this phone call. And we have the capacity to handle more. So I encourage you to fill out that lab request, and we'll get you on the schedule. We'll get you your kits, and I'm sure that there is a lab. We have 20 different topics. There is certainly a topic that would meet your needs, your instructional needs.
We have Constance on the line, and she's our point person when it comes to actually scheduling schools and classes. Constance, did you want to weigh in on the logistics of that at all?
Good morning. This has all been really exciting. So many of you, I've been private chatting with you and have given me your information. So you have my information in there. I'll pop it in there again before we conclude. As soon as you fill out that registration, I will contact you in short form. What I need is we can talk about curriculum and find the labs that are right for you. I will need your course schedule because we customize this to your school calendar and to your class periods. So the number of students, your course times, and the calendar week of topic that you're interested in. And as we'll get this done like today, if you give me your information. So thank you so much. This has been a great group. And Milton, fantastic presentation as always.
oh, thank you so much, Constance.
Can I add one more thing to sweeten the pot, if I could put it this way? You know, we don't like to take money and put it into advertising because that doesn't go directly to kids. But we use social media, but we primarily use word of mouth to make sure as many teachers as possible get to know this. And we have no qualms about the following. We'll pay $100, can I call it finder's fee, to a teacher who can recommend a new school to us that we will be able to schedule. And if we're successful in scheduling that school because of that lead, we write a $100 check each and every time to a teacher who initiated that process. So if you're in a position to be able to help us get the word out to more schools, we certainly are in a position to compensate you for your efforts. So I leave that with you too. And Megan Barrett would be the contact person to really talk to if you go down that road at all. Gav, I think we wanted to be respectful of time. Is there anything else we can be doing for you and the group at this time?
Yeah, we still have some time. So if it's possible, would it be possible for you guys to talk about some of the other virtual labs that you have, just an overview? Because we have a mixture of educators here. There might be some people in this workshop saying, look, this presentation was great, but my particular CTE program is not based on aerodynamics. Are there any other subjects that you can help me teach? So can you just give a quick overview of other resources you have?
Thank you. Megan, is it possible to put our flyer on the screen?
Yes,
Yep.
Okay.
Constance,
And-
can you pull that up? And then I'll also drop in the chat. We have that you can take a look at pages. I think it's 6 and 7. We have a document that gives
Matrix.
a brief summary of each lab topic, but then at the end of the document, we have 2 matrices that actually align the different engineering disciplines with the labs, and that also align the core high school math and science subjects with our labs, so you can see directly what correlates. So I'll pop that in.
And Gav, if you allow me to share my screen, I think I will be able to.
Yeah, you're a co-host, you should be able to.
Great.
Good point, Gav. I really appreciate you raising that issue. So thank you.
Yeah, no problem.
Okay. And
It's
to my colleague, my engineer tomorrow colleagues, let's tag team this part of the agenda. I'll make a couple of comments, and then if you'd like to weigh in on any of the other labs with a narrative or anecdotal comments, please do so. So I'm going to guess that's large enough for you to read, and I'm going to make a general comment as you're reviewing those there. Here's what I think one of the terrific aspects of what we do. One, we raise an awareness level of all of the types of industries that the engineers are engaged in. But as we do that, we educate kids about what the world problems are out there that need to be resolved and to be resolved by an engineer. And then as we have that conversation with them, we're sharing with the kids engineering's an iterative process, which means you identify a problem, you design, you test, it will fail, and you replicate that process, and you're repetitive about doing it until you come to a conclusion. We want the kids to have that experience of failure and then to analyze what went wrong and redo the process again. So when you get to bridges, we give the students the materials, we give them the wooden dowels, the popsicle sticks, the electric glue gun. We give them the metrics on how they create a bridge, and then we give them an understanding of how they need to test that bridge for strength, with the understanding it will fail. And then we engage the students, okay, analyze how it failed, and let's do it again with a different perspective on how to make that bridge bigger. Water treatment is one of my favorites, so I'll just personalize this because, you know, we're all blessed. For the most part in this country, we have access to water. Obviously not true in much of the world. So we tell the students 0.2% of the water on this earth is usable by us. The rest of it's captured in glaciers and oceans. And we talk about desalinization, obviously it's the process, highly expensive, particularly for third world countries. And then we start to delve into what we want to talk about, which is a technical term called water reuse. And I love it when we educate the kids to say the city of Singapore can recapture 3 out of every 4 gallons that has gone through their cycle. And we blow them away when we say, yeah, even the stuff that's in the toilet. And then we help them understand what an engineer does in that process in order to clarify the water to make it useful again. So they're getting all kinds of more information than just going through one particular lab. And we try to do that, and we do that with all 22 labs. We don't do this for all 22 labs, but for a fair number of them, we'll bring in one other aspect that students should have an understanding of. Engineers are not free of economics, and finances weighs in very much in what they have to do. So with bridges, if I could go back to that example, we'll put a price tag for every piece of material they use in building that bridge. So the objective is not to build the prettiest bridge or the strongest bridge. They have to also juxtapose that to, did they do it economically? And they have to weigh the cost that goes in. So let me just stop at that point for Milton, Megan, or Constance, if you'd like to add some more comments to give help our folks give a better understanding what's in this list. I'm delighted if you would.
Yeah, Tim, I think you hit a lot of the great labs, and I really love how you talked about as engineers, the triple constraint, right? When we're designing something, especially as a project, there's the balance of cost, schedule, and performance. And, sometimes perfection for us as engineers and scientists, perfection is an enemy of good enough. So we talk about that triple constraint. You want to satisfy the customer's needs while balancing cost, schedule, and while meeting the requirements. And that is the challenge of engineers. It's not perfecting the design, but it's making something that meets all those objectives. I think I'm not seeing the screen with the labs anymore. It seems like we're scheduling already some of these labs for you folks. I'll share my screen just so you can continue to
Constance, can we go back to
look at
the list? Did we lose you, Constance?
I'll take over and just say all the labs are also on our website, Engineering Tomorrow Labs. And as a teacher, for my class, I'll tell you, I have a class in Tacoma County that I help lead. This is what I did. I have an intro to engineering design program. I went on the website and I identified some outstanding labs. I mean, Bridges is outstanding. I mean, some of my students are very much interested in biology. So, we really tapped into bioinformatics, and some of them were interested in coding. So the robotics lab and the networks and drones labs were just really, really great for them. And then a lot of them are interested in our carbon footprint and how we innovate in an energy space to reduce the carbon footprint and develop products that will have sustained energy. So for those, electric vehicles, solar power, the power grid, and wind power are just excellent labs where students, like 3 or 4 of them, they actually get hands-on parts that they can develop something where the energy is sustainable. So I feel like I'm from the Hair Clubs for Men. I'm not just I'm not just saying this to you as an engineer that's with this great team, as a staff engineer that's with this great nonprofit. I've used the products and I continue to use them. So I can vouch for it for sure.
Milton, thank you for that. And because we don't charge anything, we're not interested in patents. So transparency is what we're all about. Milton alluded to go to our website. If you do and you click on that curriculum tab, what you will find for each lab, you'll see the PowerPoint and speaking points that the engineer uses. You'll see the student workbook that's given to the students so that they can work on that particular lab when they're not with the engineer. You'll also see the teacher guide that we provide the teacher so that they can follow along and be supportive of the students while they do these labs. All of those resources are on our website at your disposal.
I just put in I'm sharing my screen. I'm hoping everyone can see it. This is a document that I shared in chat. So prior to this is about page 6. The previous pages give about 3-sentence description of each lab, but then you'll see this matrix. This shows which labs align with some of the core subjects.
Yeah,
that's great.
So this is a really helpful tool as you choose your labs. To kind of state the obvious, we can handle, any number of students and classes that want to participate. So, if there are 10 labs here that sound interesting to you, sign up for 10 labs.
I'm back to bragging, so forgive me, but everything we're doing here was a collection of not only some terrific engineers, but our team has a lot of educators with high school experience. We blend all of those dynamics together to create these products. So I think they really show a great sensitivity of where you are at and what your particular needs are at and where students are at in their development.
That's a great point, Tim. And also I'll just say that it's very flexible as well. There have been times where, I have a good handle on some of the material. So Engineering Tomorrow, they'll come in and they'll present session 1 and session 2, and I'll just do the wrap up for my students myself. There's flexibility here, right? And all the curriculum was given to me. So if I felt my class was already providing some level of rigor, I was able to real time add additional challenges, add additional activities right to the great foundation of the material Engineering Tomorrow already gave me. So there's a lot of flexibility here as well. It's really a turnkey operation. and the key's in your hand, you know.
This might have already been stated before, but if it wasn't, it's worth sharing. So after an engineer like Milton gives that introduction presentation, the students go off and they use the toolkits that Engineering Tomorrow has provided, and they use their student interactive workbook. Now Engineering Tomorrow hasn't left at that point. We're still there to support you. Our 2 other Zoom calls allow students to have questions answered as they're doing the Engineering Tomorrow challenge. So when they come on the call with those college students, they engage in open Q&A and learn about the college students' experience, but our college students are also well-versed in the labs. So if your students are having any difficulties with the labs, those college kids are there to help. And then that final Zoom call with an engineer. So it really, it's full circle with each lab. Engineering Tomorrow ensures that every student has success. So we don't just tee it up, we make sure that it finishes, and students have the whole experience and have all questions answered.
Thank you, Megan. Thank you, Tim. Thank you, Milton. Are there any other questions from anyone in attendance? I did get a question about can these activities count as work-based learning? I would say that you should check in with your program quality manager. There's sometimes some internal debates that we have in the CTE office about what counts as a proper WBL activity or not. So just check in with your PQM. But again, if you have any lessons that you think can benefit from Engineering Tomorrow, I really, really do encourage you to sign up. And it's not just aerodynamics, it's just everything that you teach, everything within STEM. So please make sure before you log out to sign the attendance. And again, there's no cost to you. Lots of time educators hit up the CTE office asking about free resources. So this is it, all right? So I'm gonna drop the attendance link in the chat box one more time. Please take about 2 or 3 minutes or so before you log out to fill that out. And if anybody has any direct questions for me, I'll be around all day in case you need to talk with me. But thank you again, Tim and Megan and Milton, Constance, all of our partners from Engineering Tomorrow. I really, really appreciate you and the time and the resources that you have.
Well, Gav, I'm going to steal a comment, a word you used earlier. Thank you for your partnership.
Oh yeah, you got it.
Yeah.
Gav, do we use the same link when we come on at 11?
I'm going to send you the new link just to be on the safe side, because I did create 2 registration links. The second session is not going to have as many people, but I will email that to you in the next 15 minutes or so.
Thank you.
You got it.
Okay. Talk then.
All right. Thank you all.